If you want to add another dimension to your data, you can use nesting. It's a little bit like having layers, but having it on one table, and it's what I want to show you now. In tabulation, rows or columns, or both, users may nest one set of variables or groups within another set of variables and/or groups. This two-level hierarchy will allow you to tabulate every combination of groups across the hierarchy. It's useful as an alternative to creating ad hocs or to using layers when running tables. And remember, when you're looking at nesting, the base for the nested items can be viewed in two ways. The default is known as V%. This can be changed to NV% within settings. In this first example, we're using the default setting of V%. V% for the nested item is calculated in the same way as it is for the group under which it is nested. The V% of the nested groups, we have 11 and 9%, is the weighted count of the group. So we have 1.9 million men here, and we're dividing it by the weighted count of the total, i.e. all people aged 14 plus, 17.3 million people. And that gives us 11% of all people are AB men. And we have 9% of the whole population are AB women. Because the sex variable is nested within the socioeconomic variable, the V% for men and the V% for women adds to the V% for all ABs. This is example 2, again using default setting of V%. H% for the nested item is calculated in the same way as it is for the group within which it is nested. The H% of the nested group is the weighted count of the group divided by the weighted count of the total. This tells us that 11% of people are AB men, 9% of people are AB women. The H% for men plus the H% for women adds to the H% for ABs in total. Here in example 3, we're again using the default setting of V%. So we can see that 24% of the population agree with this statement. 10% of the population are men who agree with the statement. 14% of the population are women who agree with the statement. If we come to the column, we can say 14% of 18 to 24-year-olds agree with this statement. 6% of 18 to 24-year-olds are men who agree with this statement. And 8% of 18 to 24-year-olds are women who agree with this statement. So you can see that when we're nesting, we're joining together the group with the nested group. Just to clarify, example 3, here we have all the 18 to 24-year-olds, and 14% of them agree with the statement. I always think about the number of calories in the food I'm eating. From this 14%, we can say 8% are women and 6% are men. Here we have example 1 using the alternative setting of NV%. When you change the setting to NV%, this provides an NV% value. This is the nested vertical for each nested group. NV% for the nested group is calculated as a percentage of the group under which it is nested. The NV% of the nested group is the weighted count of the group. Here we have 1.9 million men, divided by the weighted count of the group within which it is nested. So here we have 3.4 AB quintiles. And this tells us that 56% of ABs are men. Here we have example 2, again using the alternative setting NV%. This is where we have nested columns rather than rows, and this adjusts the H% value for each nested group. The H% of the nested groups is the weighted count of the group divided by the weighted count of the group within which it is nested. So this tells us that 56% of ABs are men. Finally, example 3, using the alternative setting NV%. Here we have all the people who agree with this statement. We can say that 41% of all the people who agree with this statement are men, 59% of all the people who agree with the statement are women. Here we have 155,000 18 to 24-year-olds who agree with the statement, and of those we can say 41% of 18 to 24-year-olds who agree with the statement are men, 59% of 18 to 24-year-olds who agree with the statement are women. To clarify that, here we have all the 18 to 24-year-olds, 14% of whom agree with the statement, I always think about the number of calories in the food I'm eating, and this is a weighted count of 155,000. So we take this weighted count and that becomes our 100%. Of this, we can say 59% of them are women, 41% of them are men. So now we're going to switch to Asteroid to have a look at putting together a nested table. I've created a table here where we're looking at family and home agree statements and age groups. First of all, I'm going to go to Selection and nest a variable under the family and home agree statement, so we have nested rows. For this, I'm going to include the variable sex. Having added that to the rows, right mouse click on the variable you want to nest and choose Nest Selected Items, and you can see that it's now nested. So here we have the family and home agree statements with men and women as nested items. Then the next family and home agree statement, again with men and women nested. And this will be the case for each of the items in the rows. So we need to look at how to read this data. This is probably the most straightforward, easy to use form of nesting. First of all, we can say that 64% of 14 to 15-year-olds agree with the statement, I love to cook. If we come down to the nested items, we can say 28% of 14 to 15-year-olds are men who agree with the statement, I love to cook. 36% of 14 to 15-year-olds are women who agree with the statement, I love to cook. So, as previously mentioned, you're joining up the nested item with the group under which it's nested. And you can see that the V% for women plus the V% for men totals the V% overall for the statement. Note that that's not always going to be the case. It depends on rounding and how many decimal places you have showing. So we'll have a look at changing the default setting. Go to Settings Task and Bases. And here we have base for nested items. The default is V%. Inherit the context from the branch under which the items are nested, which basically means that the nested item is calculated in the same way as it is for the group under which it's nested. I'm going to change that to NV%, and here we're basing to the branch under which the items are nested, which means that the NV for the nested group is calculated as a percentage of the group under which it's nested. Having changed the setting, we'll click on OK to refresh the table, and we can now read the data slightly differently. We still have 64% of 14 to 15-year-olds agreeing with the statement, I love to cook. However, we have 44% of 14 to 15-year-olds who agree with the statement, I love to cook. They're men. And we can say that of the 14 to 15-year-olds who love to cook, 56% of them are women. So now that I've changed from the default setting of V% to NV%, we're joining up the column heading and the group heading when we're reading the statement. Now I'm going to have a look at nesting columns rather than rows. To remove the nest item, you can either double click on the variable and it will remove it from the table altogether, or you can right mouse click and simply choose Remove Nesting. This allows me to move that to columns and we'll nest it there instead. I'm going to change the settings in bases back to the default of V%. Now we have the age groups in the columns, and within each age group you have the nested item. So now we're looking at H% rather than V%. Here we can say that 4% of the population are 14 to 15-year-olds, 2% of the population are 14 to 15-year-old men, and 2% are 14 to 15-year-old women. We can also say that 4% of those who agree with the statement, I love to cook, are aged 14 to 15. 2% of those who agree with the statement I love to cook are 14 to 15-year-old men, and 2% of those who agree with the statement are 14 to 15-year-old women. Now we'll change the setting again. In bases, change to NV%. Now we have 4% of those who agree with the statement I love to cook are aged 14 to 15. And of the 14 to 15-year-olds who love to cook, 44% of them are men and 56% of them are women. And you can see that these two values equals the 100%. It is possible to nest both rows and columns at the same time. However, be aware that it can get a little confusing on how to read the data. First of all, I'll go back to selection and we'll make some changes here. So I'm going to remove the nesting and add that into rows. And we'll include regions as nested items under the ages. I'll also change the settings in bases back to the default of V%. It takes a few moments to run a nested table, particularly when you have nested rows and columns. So now we have the ages in the columns and the nested regions, and we have the family and home agree statements within the rows and the nested men and women groups. So we'll have a look at some of the data here. We can say that 1% of those who love to cook are 14 to 15-year-olds who live in the eastern region. We can also say that 1% of men who love to cook are 14 to 15-year-olds who live in the eastern region. So when you're reading the data, again you're joining the nested item in the row with the row item and the nested column within the column item. And the reason for this is because we're using the default setting. If we go back to settings task and bases, and we'll change it to N%, we now have to read the data slightly differently. So here we can see that 4% of the population are 14 to 15-year-olds, and we change that to an internal base of 100%. So with that setting, we can now say that 34% of 14 to 15-year-olds are those who live in the eastern region. If we begin to include the nested rows, here we can say that of the 14 to 15-year-olds who agree with the statement I love to cook, 33% of them live in the eastern region. Now for the nested rows, here we can say that of the 14 to 15-year-old males who love to cook, 29% of them live in the eastern region.